Good morning, everyone. This video is to introduce the second part of chapter 20, starting from 20.7. This section introduces the static methods for lists and collections. The collections class defines the static methods for sorting a list, for doing a binary search in a sorted list, and for reversing a list, for shuffling a list, and for doing some other things. And also the max, min methods for finding the maximum and minimum element in a collection. And please read the foreign text and see the examples of using these methods, and do the self-check and using the checkpoint and multiple choice questions. Now let's look at the next section is a case study for the bouncing ball example. Let's look at the program. When you run the program, you can click the plus button to add a new ball. Click the minus button to remove a ball. And use the slider to control the speed of the ball. And please take your time and to study this case study. Next, this section introduces the two legacy classes in the Java collections framework, the vector class and the stack class. The vector class is now replaced by the ArrayList class. These two classes, a vector and ArrayList, are very much the same, except that the modification methods in the vector class, such as add, remove, and are synchronized. And in the ArrayList, and the modification methods are not synchronized. Now, synchronizing is not efficient. It costs a lot of overhead. So they're not used. If you really want to synchronize it, there's a better way to do it, and which will be introduced later in chapter on multi-threading and parallel programming. So just note that and vector is similar to ArrayList, but it's now replaced by the ArrayList. The stack is, and here provided in Java API, it's a subtype of the vector class. It provides the methods peek, pop, push, and to test if the stack's empty and to search an element in the stack. So this is the provided in the Java API. You can use it, but it's not a good design because it makes this stack a subtype of vector, and it inherits all the methods which are not appropriate for a stack. All right, so let's move on to queues and priority queues in this section 20.10. In the collections framework, the queue interface is defined. It provides the methods pull, remove, and pick element, and offer is like a push. And linked list is actually a subtype of the queue. In the Java API, there is no concrete queue class. You can use the linked list as a queue. And the priority queue class is defined in the API. Here's the priority queue. So those are the constructors to construct the priority queue. And the priority queue is a subtype of the queue. It is so implemented, and that you always and retrieve the element with the highest priority. So this is the all the elements can be compared and using in natural order, or you can specify a comparator. And here's an example. Here we have this priority queue, and for the strings here, and you can remove the strings from the queue. Now see, here is the output is here: Georgia, Indiana, Oklahoma, Texas. As you see here, the priority is that the smallest element actually has the highest priority, and we can reverse it using this collections dot reverse order. Here is the comparator, so just reverse the natural order, and now you can get the opposite, and Texas is before Oklahoma. And please do the checkpoint questions and also the multiple choice questions. And now the last section is a classic case study on evaluating expressions. So suppose you have this expression, you entered it from the Google. Now you can see the result here. So how does Google evaluate this expression? It uses stacks. And so please study this example and see how this program is designed and implemented. And then you can go to the programming exercises in the book and do the last one here in the book, and to add additional operators. So in the book we have the addition, subtraction, multiplication, and division. So now add this two operators, the exponent and the remainder, and see how and this works, and with this additional. So if you have this, let's change this to remainder and see what the result is, and see that's the result. And let's change this to exponent, and see this is the new result. Here's the exponent here. This concludes the introduction for chapter 20. Now the purpose of the video is to give you the guideline and for studying this chapter.